Hi there. Today we're going to discuss Chapter 5, Lesson 3, Properties of Operations. What will we learn today? Today we're going to identify properties of operations. We're going to determine if conjectures are true or false, and provide counterexamples for false conjectures. We're going to use properties to simplify algebraic expressions. The commutative property states that the order in which the numbers are added or multiplied does not change the sum or product. So for example, we have 6 plus 1 equals 1 plus 6. So here we have the same numbers, we just switch the order. Well, if we add 6 plus 1, we get 7. And if we add 1 plus 6, we also get 7. So here, even though we switch the order of the numbers, the sum remains the same. And that's for addition. For multiplication, the example 7 times 3 equals 3 times 7. 7 times 3 is 21. And on the right-hand side, 3 times 7 also equals 21. So switching the numbers in addition and multiplication does not change the sum or the product. The associative property states that the way in which the numbers are grouped when they are added or multiplied does not change the sum or product. So here we have the same numbers, 2 plus 3 plus 8, on the left side and on the right side. The only difference is 3 plus 8 is grouped here and 2 plus 3 is grouped here. So, order of operations tells me to do parentheses first. So 3 plus 8 is 11. And then, if I keep on following the order of operations, 2 plus 11 equals 13. Now on the right side, I'm going to do 2 plus 3 first. So that's going to equal 5. And 5 plus 8 equals 13. So, the way that I grouped them when we were adding the same numbers does not change the answer. Same thing for multiplication. We have the same numbers, 3, 4, and 5. The only difference is 4 times 5 will be first to multiply here, and 3 times 4 is the same to be multiplied here. So 4 times 5 is 20, and 3 times 20 equals 60. Now, on the right side, 3 times 4 goes first, 12 times 5, and that also equals 60. So here, the grouping changed from the left side to the right side, but we have the same answer. So for example 1, name the property shown by the statement. We have the same numbers, 2, 5, and n, and they're all being multiplied. The only difference is 5 times n is being multiplied here, and 2 times 5 is multiplied here. So this is known as the associative property of multiplication. Okay? Here's the next example. Name the property shown by this statement. 3 times n times 2, and 2 times 3 times m. So if you take a look at this, the first thing that draws my eyes is the grouping. Well, the grouping remains the same on the left side and on the right side. So the only difference is the order in which the numbers are being multiplied. Here we're multiplying times 2 at the end of the statement. Here we're multiplying times 2 in the beginning. So this answer is the commutative property of multiplication. Example 2. State whether the following conjecture is true or false. If false, provide a counterexample. Division of whole numbers is commutative, meaning you can switch the order and the answer would be the same. Write 2 division expressions using the commutative property. So we chose 15 divided by 3 and 3 divided by 15. Well, in this case, 15 divided by 3 equaled 5, but 3 divided by 15 equaled 1/5. So this is going to be false because the answers did not equal each other. So this is false. When they ask you to provide a counterexample, this is your counterexample. This is the example that proved that the statement was false. Here's another example. State whether the following conjecture is true or false. If false, provide a counterexample. Subtraction of whole numbers is associative. Again, associative just basically means that we have the same numbers, but we group them differently. So I have an example here, 12 minus 5 minus 3, and the same numbers are on the right-hand side. But here 12 minus 5 is grouped, and here 5 minus 3 is grouped. So I'm going to go ahead and start with my order of operations, which tells me to do multiplication first. So 12 minus 5 is 7. minus 3, that equals 4. So my left side equals 4. My right side, by following the order of operations, I'm going to do 5 minus 3 first, and that's 2. So 12 minus 2 is 10. So in this case, they did not equal each other. So this conjecture is false. And the example, or the counterexample, the one that proved that it was false, is this right here. Okay, moving on. Alana wants to buy a sweater that costs $38, sunglasses that cost $14, a pair of jeans that cost $22, and a t-shirt that costs $16. Use mental math to find the total cost before tax. So what we're going to do is we're going to write an expression for the total cost. So we want to add 38 plus 14 plus 22 plus 16. Now what I want to do is when I'm doing mental math is I like to group numbers or chunk numbers together that are easier to add. So what I'm going to do is I'm going to reorder these numbers because I want to add certain numbers first. So I'm actually going to switch the 14 and the 22. Okay, and I can definitely do that using the commutative property of addition. Okay, the next thing I want to do is I want to group numbers together, meaning I want certain numbers to be added together. So I'm going to go ahead and group 38 and 22 because I want to group them together, and you'll see why in a second. And then I want to group 14 and 66 together. So this is the associative property of addition. So the reason why I like to add 38 and 22 is because that's going to give me a nice big number of 60 where there's a sum of 10. And then 14 plus 16, that equals 30. So now 60 plus 30 is kind of fairly easy to solve in my head. And that equals 90. So she's going to spend $90. I'm going to use that same concept to apply it to our garden problem. In a garden, a decorative pool in the shape of a box is 2 feet deep, 7 feet long, and 5 feet wide. Use mental math to find the volume of the water in the pool. So really quick, volume is your length times your width times your height. So your length is going to be 2, your width is 17, and your height is 5. So I'm going to go ahead and start multiplying these numbers, but what I want to do is I want to reorder the numbers. Reason why I want to do that is because I want to group certain numbers together because they're easier to multiply mentally. So I'm going to reorder the 5 and the 17, and I can reorder using the commutative property of multiplication. Now what I'm going to do is I want to group certain numbers together because I want them to go first. And that's the associative property that I can group whichever numbers I want. So here I'm going to multiply 2 times 5, and that's 10. And then 10 times 17 is so easy to calculate. So I got 170 feet cubed. Okay, so now we're going to get into simplifying, and what you have to remember about simplifying is that you can combine like things. So all your numbers can go together and all your letters can go together, but you can't combine a number and a letter. Okay, they have to stay separate because you don't have a value for the variable yet. So I'm going to start with 7 plus g plus 5. Okay, and this one is in parentheses. So what I'm going to do right now is I'm going to reorder this problem because what I want to do is I want to put my numbers together and then I'm going to leave my variables on the other side. So I'm just going to take this and I'm going to reorder the g and the 7, and that's the commutative property. The commutative property says I can do that. Okay, commutative property of addition. So now what I want to do is I want to combine my numbers together. So here the g and the 7 are combined. So what I'm just going to do is I'm going to combine my numbers first. So if I want to change the grouping, that's the associative property of addition. So now I can go ahead and add. So g plus 12. Okay, now I cannot combine my g plus 12 and make it 12g because you can't combine a letter and a number. Okay, Here's example 5. We have m times 11 times m. Okay, I want the things that are alike to go next to each other so I can combine them. So I'm actually going to switch the order of the 11 and the m, and I can do that using the commutative property of multiplication. I can switch the orders. Now what I want to do is I want to group the ones that I can multiply together. So I'm actually going to group the m times the m, and that's my associative property of multiplication. So now I can just simplify 11 times m, which is just m squared. Okay, I'm going to give 2 more examples just to practice these skills. So we got 6 plus d plus 8. Now again, I want to combine things that are the same. So I notice that 6 and 8 are both numbers. So what I want to do is I want to put them next to each other. So I went ahead and switched the order of them. So commutative property says I can do that. Okay, now I want to group my numbers together because I want to combine them. That's my associative property of addition. So I'm now going to do 6 plus 8 plus d. So now the last step is just to simplify or add. So 6 plus 8 is 14. 14 plus a d is my answer. Again, I can't combine the 14 and the d because one's a number, one's a variable. Here's my last example, a times 9 times b. So what I want to do first is I want to change the order of things because I want to keep all my variables together and all my numbers together. So I'm actually going to switch the order of b and 9. Okay, and then again, changing the order is commutative property of multiplication. And then I'm going to group the ones together. So 8 times b times 9. Okay, and changing the grouping is the associative property. So I can have a, b times 9. Now, this comes a little tricky because when we're multiplying numbers and letters, you want to make sure that when you're writing this out, the number goes first and then the letters come in alphabetical order. So 9 times a times b is 9ab. All right. Well, I hope that video was helpful. Thank you. Bye.